In this lecture, we're going to continue our discussion on file permissions in the Linux file system. As we know, there really are three basic permissions that can be used when trying to secure or grant access to a Linux file or folder. They're read, write, and execute. There are some special permissions which we'll discuss in another video, but those are the three basic permissions. And we know we can describe those permissions either with a letter or a number. So read can be 4, write would be 2, and execute 1. Okay, and that's the basic stuff we discussed last week. Now, the one thing you may not know is that when permissions or files or folders are created in the Linux file system, by default, files have a permission of 666, or read, write, read, write, read, write. And folders have a permission of 777. Which is read, write, execute, read, write, execute, read, write, execute. And you should remember that this first set right here applies to the user who owns that file. The second set applies to the group who owns the file. And the third set applies to everybody else on the file system. Now, this is interesting because when you actually create a file, you see a different set of permissions than 666 or 777 if you create a file or folder, and I'll demonstrate that for you. So first thing I'm going to do is make a sales directory, which we'll probably be using. I'll do an ls-ld sales, and instead of seeing 777, I actually see 755, or read, write, execute, read, execute, read, execute. And if I go into the folder sales and touch a file, and do an ls-l here, instead of 666, what I see is 644. Well, what's going on there? Well, what is happening is, if you remember our conversation last lecture, we discussed how the write permission is probably one of the most critical permissions that can be applied to a file or to a folder, because it really allows you to modify that document, or in the case of a folder, delete the contents of that folder, even if you do not own the contents. So Linux and all file systems have this mechanism where they filter out some permissions initially from the default file permission, folder permissions. And in Linux, that's called the Umask that accomplishes that. And you can actually see the Umask being applied to your account by typing Umask and pressing enter. Now, what I'd like you to do is just ignore the first 0. Act like it's not there. Act like all you see is 0, so 0, 0, 2 for right now. Because that first 0 applies to the special permissions, which we'll talk about a little bit later on. Well, actually there is 2 2s there, isn't there? Yeah, okay, this is root's account, and root actually has the Umask of 0, 0, 2, 2. Well, what does 2 represent in the file permissions? Well, 2 represents write. And if we look at what's being subtracted from the default permissions, remember we said on directories it's 777. Well, the Umask is basically subtracting 2 from the default mask. And once again, we still have the same placement. So the first 0 applies to the users, 2 applies to the group, and 2 applies to everybody else. Now this is the Umask value. And if we look at the permissions, if we were to look at the permissions that are by default and go, okay, 6, 6, oh no, that's files. Let's get rid of that. 7, 7, 7, and then what we're subtracting is 0, 2, 2, right? You can see where what we're seeing up there, which is 7, 5, 5 comes from. So basically, it's just a way of removing the write permission initially from the default permissions. And the same thing happens with a normal user. And you can actually see the two default umasks apply to either administrative users or normal users by going and looking at the bash rc file. So let's go look at that. It's under etc bash rc. Right here, you can see this little line that says basically if the user ID is greater than 199, apply this umask right here, which is 002. Otherwise, apply this umask, which is 022. So we even get a more restrictive mask for the administrative accounts like root, because root is ID 0. So that's the default umask, and you can change your umask if you want to and make it something else. No reason to do that I can come up with for normal users, but in special situations you may want to do something like that. All right, let's get out of there. So once again, the umask just subtracts or deletes the initial write permissions that are set on files and folders depending on who you are when you log in. Right, the other thing we talked about was the smod command, and we started looking at the smod command or chmod command, whichever way you'd like to say it. And that command allows us to change permissions on files and folders. Once again, we can do it two different ways. We can do it with the letters representing the permissions, or we can do it the numeric way with the numbers representing the permissions. Key with this is just to remember that a 7 really is the same as saying read, write, execute. So 7 is equal to RWX because this is a 4, a 2, and a 1. It really is important to remember when using the numbers and applying permissions. So let's see how both of these would work on a particular file. All right, what I'm going to do is I'm going to touch a file called test file. And then I'm going to smod that file. And what I'm going to do to just practice a little bit is literally take all permissions away from it, and then we'll add permissions to it. So I want to take all permissions away, so I will say 000 using the numeric value for the permissions. Well, if I put all 3 zeros there, that means there's no permissions on the test file. And we'll do that. And then we'll do an ls-l here. And you know what, I'll get rid of root file just so we don't have any issues with that one. Nobody gets confused about it. All right, there we go. So there is our file, and we'll zoom in. Whoops. Come on. Sometimes it just doesn't want to do it. Go in this way. All right, and so we see there's a file here, and there are absolutely no permissions set. There is a user owner, root, and there is a group owner, also root. But right now I've deleted all permissions because I want to show you how we can add permissions at the command line using the smod command. So first thing I'm going to do is add read, write, execute to the user using the numeric way of doing it. So 700, right? Once again, remember your place values. The first 3, or I should say not the first 3. The first bit, that first section, always represents a type of file. After that come the 9 possible bits that you can use for permissions, or dashes you can use within the permissions. So this first 3 right here is represented by that 7. So I'm saying give all permissions to the user. Press enter. You have to tell it the file you want. And sure enough, that's exactly what we see. And you'll notice that the color of the file has changed. It's kind of a yellow-green, and green usually signifies that the execute has been set on a file. Even though that file is completely empty, the system sees an execute, so it says it must contain executable code, so we'll mark it as green. And so you can see that colors are not wholly reliable when working with files. Well, let's try to now Smod the file, and what I'd like to do is remove write permissions. Once again, this is all about testing. This has no purpose to it right now, just to get used to the fact of using the Smod command. So that's the group, or that's the user position, and I want to remove the W. So logically, I would say user minus W. All right, so user minus W, and then the name of the file. And there you go, we remove. Now, same thing, if I'd like to remove just the execute from there, same thing, U minus X test file. Enter. Of course, you do have to put the Smod command in there. Dash ls down, and sure enough, all we have left is the read permission. All right, so let's add those both back. We took them away, and now we want to give them back to the user account. Think about that for a second. If U minus, W and U minus X will subtract them, then U minus, so Smod U plus X, or even W and X. Right, we can actually clump them together because we want to give back both of them. All right, so we can do that. Press enter. Keep forgetting the file. Too much talking, not enough watching. And sure enough, right, that command right here allowed us to add both of those permissions back in. So just take that to the next step and say, well, what happens if we want to add permissions to the group? And what happens if we want to add permissions to the others? And that's why you always see me describe that last set of permissions with an O, and that's why we describe it as the others, because that's the way we designate it as far as assigning permissions or modifying permissions. So I could say I want to add the permission of execute, G plus execute to the group. Or as a matter of fact, I could say I want to do everything, read, write, and execute to the group. And I'll do that. And now we've given all permissions with one command to the group account. Last thing we'll play with is adding permissions to the others position, everyone else on the system. We don't want to give them right to the file, even though they technically can't really get to it right now. We can modify that at the folder permission, the folder level, I should say. But we don't want to give them, right? Good practice not to give permissions to everybody on the system unless they really need it. So we'll Smod O, not 0, right? Because 0 represents the actual read, write, or execute, no permissions. O is for others, plus read, execute. And there you have it. Well, let's go back and start that all over again. Let's do that again. Let's go back and say smod 000 test file. No permissions. Well, if we look at this, what does this represent numerically? That would be a 7, that would be a 7, and that would be a 5. So I could do this one or two ways since we have no permissions. And if I wanted to set this exact set of permissions on here, I have two ways of doing it. If I wanted to set it all at once using the letters as opposed to numbers, I would type smod, and then it would go u plus read, write, execute, comma, g plus read, write, execute, comma, right? I'm just separating the different fields, and then o plus read and write. That would work. Right, that works for us. Oops, did I give it the wrong permission? I guess I did. I meant to give it execute. Let's go fix that. There you go. I gave too many permissions to it. Oh, perfect example. Here's a perfect example of how things can get a little squirrely. I wanted to give read and execute, but I accidentally gave the write permission. Well, when I up arrowed and changed it to read and execute, I never told the system to remove write, so it didn't remove write. So that permission is right there. So now I would have to subtract that permission from that group before I actually added in there. So you see, you can string out this long line, right? We could string out this long line, a lot of typing, possible typos like what just happened right here, right? Possible typo right there can happen. The other way, if you're going to set all permissions in all areas, so user, group, and others in one shot, then you're better off using the numeric way of doing it. As long as you understand the values that you're inputting, that's actually the easier way to do it. So let me get out of there and then Control L. So I want to smod that file, and the original were read, write, execute, which is 7, read, write, execute, which is 7, and then read and execute, which is 5. That's the same set as that long drawn out line you just saw a second ago, and I type it against test file. And voila, there you have it. We now have our new set of permissions set nice and easy. Here's the only caveat there is with numbers. You look at the number and you go, wow, I understand that read, write, execute is 7. I understand that 5 equals read and execute. I've got that. Great. I'm going to use the numbers all the time because it just seems easier to do. And it is easier if you're setting all the permissions at one time. If you're setting just one permission, let's say I just want to remove read from the user. Well, I would think about that, and I would have to, if I was going to do that, I just want to remove read. What I would have to do is look at the original permissions and go, okay, that's a 7. I got to remove 2. So 2, that's going to be a 5. That's going to be a 5, and then, I don't want to remove anything from the group. Okay, that will be a 7, and this one's still going to be a 5. Great. This is another way that it's really easy to make a mistake. You may assume you know the permissions on the file, but maybe you're busy and you don't, and you make an assumption that these are the permissions on the file, and you change everything, and you change something that's incorrect, and people lose access, and that causes a lot of problem. So if I was to come up to you and say, hey, I'd like you to remove the write permission or the execute permission from the others group, instead of using all numbers, because you cannot do 0, 0, minus, you can't say minus, O minus and then the number 1, that doesn't work, right? So, right, that's going to come back and say no, that doesn't work. You also can't just leave the others blank. So if you put a 0 there and put a 1 here, you're not going to end up with what you want. You're going to end up with no permissions, no permissions, and execute, which is not what we want to do. Our directive is just to remove the execute permission from the others group. And so the easiest way to do that is to say, okay, minus X test file. So it's really important to understand the two different ways you can use the permissions. So either with a letter or a number, but it's also important to understand that there are better uses for one over the other, right? So there are situations where one is a better use of setting permissions than the other. So the way I look at it and the way I always go about it, if I'm creating a directory from scratch, a brand new directory, and I know what permissions I want to set there, for instance, I'm going to create the HR directory. I'll say HR, and then I'll say I know what permissions I want to set on HR. I want only the HR group, which we'll give ownership to in a second. So I only want the group, which means it's going to be 070, to have permissions to HR. Didn't do it. There you go. So that is the easiest way to do it with this smod command. So in this one, what I did was make the directory and then smoded the file HR and left off the L here, which it would have displayed it. Now there is an easier way to do this, right? You don't have to run all three commands, or at least the first two. The easiest way to do it is when you're making the directory, use the M option, set the permissions there, so 070 and HR2. That not only makes the directory, but this M from modify or mode changes the permissions while you're creating the directory also. So very, very convenient way to do it. And that's usually the way I will use the numeric way of setting permissions, only when I'm creating a folder or a file and I know what those particular permissions need to be. If it's already created, like the sales one is, and you come up to me and say, Ed, I need you to add read and write to the user, I wouldn't even have to look if you're giving me that directions. Now, of course, you'd probably want to look, but I wouldn't have to. All I would have to go is say, okay, I was directed to add read and execute to the users. Smod u plus read execute /sales. And this, I don't even have to look at the directory and what the current permissions are, because that's what I've been told to do. And that changes nothing else but adds those two permissions. Oops, forgot the L again. Right, and that adds those permissions to it. Let me go back and make sure I'm looking at the right one. Yeah. So that adds the permissions. If they were already there, it doesn't do anything, right? But if they weren't there, it would add those permissions to that particular directory. So that's the two ways you can go about modifying permissions. Now, we have a sales directory and we have an HR directory. That's great, and obviously we want to create a sales group, and we want that sales group to be the group owner of this directory, and that's where that chown command comes into play. So we're going to create the group, make them the owner, and then modify the permissions so that only that group can have access to that particular folder. So the first thing we'll do is group add sales. There's the group. Next thing we'll do is change the ownership. So we'll chown sales. And remember, think of a little dot between the user and the group. I only want to change the group. So if the user is on the left side of the dot and the group is on the right side of the dot, all I have to do, since I only want to change the group, is leave the left side blank, dot, and then sales. That will accomplish it. It's the same thing as doing this. Same thing. And sales. So we are changing the ownership, which right here is root, and we're giving ownership of that folder to the sales group. And sure enough, there it was originally, and here it is now. Next thing we would like to do is smod it so that only sales has permission for that. So think about that for a second. What would be the correct numbers to use here if I want to make it that only sales has read, write, execute to that folder? Hopefully your answer is 0, 7, 0, right? User nothing, group everything, everybody else nothing, /sales. ls-ld, and there we go. So you've seen two basic commands, chown and smod, and how they can be used to manipulate and to secure and to grant access, because we want to prevent everybody else from getting into the sales directory, but not the members of the sales group. Now, there is a problem with this, which we'll discuss in our next lecture. The write permission to the sales group, which means, as we remember, anybody who's a member of sales can delete anybody else's documents, folders. It doesn't matter, because they've been given this special write permission. Now, there are 3 special permissions that we can use to help us prevent, careless or reckless deleting of other people's files in the sales folder. There's something called the sticky bit, the set group bit, and the set user bit. Those 3 bits are used in situations like this, where you need to protect a particular folder from users accidentally deleting items that do not belong to them. And these permissions are used throughout the file system. The one I'll start out talking about, and then we'll finish this in our next lecture, is the set user bit. The set user bit allows me to run the file or usually a application or a utility in the context of the user owner. The best example of this is what happens when you, as a normal user, change your password. So I'm going to exit out of here. Actually, no, I'll just switch over to another terminal. Here I am as student. I can type pswd and change my password. It will let me do that, right? Makes sense. I can change my password. Now, the user student has no special privileges. I mean, the user is the most basic user we have on the system. But let me show you the file that's being changed by that user. So I'll just gotta remember which utility. Oh no, I know where it is. Oops. There's the permissions on the file that I, as the user student now, remember, a student has no special permissions, I'm modifying that file, shadow, and look at the permissions on that file. There are no permissions on that file. And I shouldn't have the right, and I'm not picking it up from the directory either, because if we go look at the directory of Etsy, and we look at that, here's the only place that I, as student, could possibly pick up something that would allow me to modify it, and I don't have the right permission to the etc directory. So there is no way that I should be able to write to that file. But when I change my password, that's exactly what's happening. I'm writing to that file. How's that possible? That's possible because of that special set user bit. Remember, the key to the set user bit is that it runs the utility or the application with the privileges of the user owner. So what application am I actually running when I change my password? Well, I'm running the password utility. Well, the next question is, what are the permissions on the password utility? And if I type ls-l, I think it's bin password. No, I don't know where it is. I always forget where it is. So we'll just do which password. It's in user bin. Okay. So ls-l/user bin password. Alrighty. First of all, we see this horrible red line going across here, which doesn't really mean anything, but it does draw your attention to it. But I want you to look at the permissions for a second. Look at the permissions. These look normal. These look normal. But wait a second. This one, which is the user permissions, looks a little different. There's an S there where the X normally is. That S is the set user permission. And that bit being set, that S bit being set there says when anybody, including student, types the password utility, they are going to run it in the privilege of this user. And who is that? The ultimate user, root. So the set user bit, right, it's the S bit set in the user position, allows me to run an application or a file in the context and with the permissions of the user owner. Usually it is used with system files like this, and it's used to be run in the context of root. But it can be used for any number of reasons, but that's its most common use. That's how I can change that file that I have no permissions to, because root can do anything. So while I am in as student, and I'll clear the screen, while I'm logged in as student and type password and press enter, when I type my new password and press enter, I'm running that file, that utility, with the power and privilege of the root user, and therefore I can change that file. So besides the set user bit, there's also the set group bit, and then there's something called the sticky bit too, and we'll discuss both of those in our next lecture. I will be updating the calendar over the weekend, moving it forward to finish up the class. So please check over the weekend. You should see some new assignments going up there. Alrighty, everybody. Well, thank you so much, and have a good weekend. And I will see you all, I'll talk to some of you anyway, online on Tuesday. Thank you.